This conference will now be recorded.
Okay, everyone, welcome to Friday. Welcome to our weekly meeting. So today it's Ali's Architecture Revisited discussion. Is anybody new who'd like to introduce themselves? Anyone interested? Going once? Okay. Let's see where. Hey, DJ, you had something. This is your ad, the OAM tool deep dive.
Yeah, so I added that based on the last week's presentation from the OAM team.
Okay.
I have put this as a potential idea because there was a discussion by Song from Intel, and they talked about OAM tool, which is a software piece.
Okay.
And I think it would be a good idea to know what is this open source tool, which is used for managing, diagnosing, controlling OAM, because some of those software interfaces are applicable for ODSA based systems as well if we integrate it in OAM.
Makes sense. Do we have like a date and a presenter, or this is aspirational right now?
This is aspirational. I need to check with Song and Whitney. They committed that yes, we will be happy to come and do a deep dive, but I didn't get the date from them. And this February 5th was a TBD. So I just kind of wrote it, but it's aspirational at this point.
Okay. All right. Sounds good. Then is a co-packaged optics. Yeah, there's a lot of interest in that. So anybody have any topics they'd like to bring up? And we have all these speaker ideas floating around. Shreyas, you want to pencil in Debendra from Intel, or I reached out to Professor Flynn from Michigan, but he was busy the last time around.
Yeah, so Bapi, tell me which date you want him to come and present it, and I can.
So pick a Friday. I mean, basically any slot. So you can see we're fairly open from now on. So pretty much, I think if you can pick a Friday and pencil it in, then we're good. I know Jim Finnegan from Metronome wanted to come in, so that's going to be one of these Fridays. So those. Anybody else have any other speakers, thoughts, topics you'd like to find out more about?
Bapi, you know that we have this business work group for chiplet enablement. Maybe we can, because we have very sparse attendance in that work group, maybe I would like to bring it here so that, remember, we are thinking of planning a workshop, but we are still not having all the right contacts put in place, and we will discuss more at 9 a.m. But I would like to bring maybe 15 to 20 minutes topics whenever you want.
Okay. Do you want to go next week or the week after?
I can go whenever, like maybe next week if we have.
So you can go at short notice, right? Okay.
Again, whenever you want, even if we have time, I can cover today as well, where we are and what are we looking, and otherwise next week.
Okay, sounds great. And then there was one other topic I was thinking of. Right, Diport with NXP, and Gary Miller is ready to do another release, so that's on the agenda.
And one more topic I want to put it out, which is not like something I want to bring, but it's something I want to put it out in the community and then see how we can think of. So in a lot of accelerators and a lot of AI ML, we use HBMs, and these days the way the thermal management looks like, we sooner or later in HBM2E and HBM3 we will hit the some challenges with the HBM. How do we cool that? And there are companies who are even looking lidded package with the HBMs. So any thermal management or discussion around HBM thermal management?
Okay, I'll put that in here. So I'm saving the top for where I know there are confirmed speakers on a specific topic, and I'm putting the wish list at the bottom.
Sounds good.
Okay, so we had a bunch of ideas
here.
Okay,
here's another suggestion for a speaker. I don't have a contact there, but we're CEA Letty, in Europe. They seem to do a lot of chiplet designs and stuff. So if we have any contacts into them, it'd be nice to get there. They seem to, I've been suggesting a lot of pie in the sky researchers, but these guys I think are closer to something that could actually be done in production.
Okay, these guys I actually can reach myself. Okay. Memory, all right.
And Bapi, I wanted to add one more idea on this list. I think there is a company which I plan to talk to through a friend of mine. They do very short, ultra short reach optical interconnect, and so not quite CPO type. And I'm trying to see if they can come and talk to ODSA community on what they are doing. So the company is called Avcena.
Sorry, how do you spell that?
Avcena. I think it's a new company of some sort. So I think we should put that on the list so that.
Okay.
Yeah, and I'll work on that. Thank you.
Okay. Well, this is a good list, and then I'll follow up offline with about memory. Memory is the thing. I think there's more and more interest, and we need to get something going. And TSMC. Those are our two big gaps in my mind. And then I'm going to move Debendra. So Shreyas, if you're going to pick a Friday, I'll just move them up here. Okay, perfect. The second thing I want to tell everyone is that the CFP is out for the Bow test chip. We've been sharing it with quite a few people. The response is, the initial response has been far more positive than even more positive than we'd anticipated. So, Suresh, anything you want to say about this?
No, I think it's early days. I think hopefully by next week we might have more to share with the group.
Yeah, so please feel free if you know somebody who would be interested in building a test chip in collaboration with the group. We're proposing a couple of interesting options to collaborate with the OCP. Feel free to share this with anybody and everybody you'd like to. Universities, companies, you name it, we're open to they're coming in.
Hey, Bapi, so on the memory one, do you have any particular, I mean, obviously I guess I kicked some of this off. Do you have any particular views on the memory side?
Well, I was thinking Samsung, there was a gentleman from Samsung who I should follow up with, and from Micron. Micron, I don't know anybody. Actually, I do know someone. I guess Micron and Samsung were the two big names I was thinking of that we really hadn't heard from.
So are you thinking about memory from specifically an HBM perspective, or a composable memory being transceiver attached like OMI, or honestly, my view of, every processors all talk memory, so why not only make the interface memory? Obviously we've had these sorts of discussions, but I guess I've not got really any traction on a normalization.
No, I'm thinking of more generic discussion around if you had memory as chiplets, SRAM, non-volatile RAM, or something like what's the OMI, the OMI chiplet, or if you had memory as chiplets, whether to an external serial interface to DRAM or Gen Z, or on package SRAM or NVRAM, what the interfaces would look like and the protocols would look like.
Okay.
Bapi, I know a couple of people at Samsung. So, director of product marketing for the DRAMs as well as SSDs and all. If you want, I can bring them here, or at least send them an email and check whether they are interested in participating. Yeah.
Rest assured, my answer to if you want is always yes, I want. So please, yes.
Okay. All right.
Yes. Thank you so much. Yes.
All right.
Yeah. Basically, there seems to be an open topic across the board. Okay. Yeah. So please share the CFP. We're really interested in a collection of responses, because we'd like to put together a consortium of companies. We have a company that's offering to do the package so that we can share it across multiple test chips. So we're really trying to create a reusable infrastructure and ecosystem here. Okay, In that case, anybody have any opens? Because you know how Ali is. Once he gets going, his topic tends to provoke an extraordinary amount of discussion. So if anybody has any opens, now is a really good time to speak up.
This is Bill Chen. I want to
Yes,
mention that we have a heterogeneous integration roadmap annual meeting, and it will be on February 24th to 26th. It will be from 7:30 a.m. to 12:30 p.m. On a Zoom platform. Everyone is invited. I will send over the materials next week for registration. Everyone's invited and it's free. So I will send over information next week for registration. Thank you.
perfect. Oh, thanks, Bill. And Ravi, now that you mention it, MEPTEC is holding a workshop on Too Hot to Test, specifically on the topic you care about.
Do you know when it is?
Yeah, I do. So I'll add the CFP to this, and it's in February. Shame on me because I'm actually on the PC. But if you have any thoughts, requirements, you're more than welcome to share them there.
Thank you, Bobby.
But okay, this is happening.
9 through 11.
Sorry?
9 through 11. February 9 through 11.
Oh, thank you. It's Ravi. I don't think it's too late to get. I mean, if you have some specific thoughts, let me know. We can. I think the organizers were open to adjusting the agenda. I think I'm not. I don't speak for them, but we can find out.
Bobby, maybe you and I can connect offline and discuss this.
Yeah. So, thank you. Thanks, Bill. And anything else? Ali, in that case, it's all yours. I'm going to stop sharing.
All right, thanks, Poppy. So I think everyone here is pretty familiar with this discussion already. We've been talking about platforms and what we're trying to do here. What I thought I'd do is let Anu kind of start by framing the discussion a little bit. She thinks of it in a little bit different way than I do, so I think it's helpful for different reframing. And then I'd like to continue the discussion. I'm happy to let it travel where it will, but if we can, I'd like to kind of have a consensus view about what we would call a platform, what we would call a subsystem, and what would and I'm going to be working toward an outline of what a white paper would look like. And at the end, the ask will be who would be interested in helping to write a white paper, basically advocating for a platform approach and defining that, and what problems does it solve and that kind of thing. So Anu, do you want to share, or do you want me to share, and you can just tell me to change screens, change the slides?
I think Ali, if you share, because I only have a preamble. So
okay. All right, so let me start from here and somehow. There we go. All right, so go ahead, Anu.
Okay, so this is essentially a continuation of what started as a lightning or an open mic, where we had these broad ideas of how do we modularize this thing. What point do we get where it's easy to sort of a plug and play? And then Ali took that to the next point where he started defining platforms and subsystems. And I think that discussion ended up with a fair amount of discussion within the group, because there were people thinking, are we going to a next level too quickly as opposed to just the chiplet level? So I'm sort of thinking of this as two steps. So Ali, if you could go to slide number 3. So this is what Ali had defined as, he had his platform and he had these subsystems. each subsystem could be a bunch of chiplets put together by itself. So keeping this concept in mind, if you go to slide 4, last week they presented the NIC 3.0 standard, and that was really a universal board, and they had the OEMs, which are all standard form factor and conveniently look like each other, and so it's identical. So the system in the middle that I have is sort of replicates the NIC standard. If we think of this in two different ways, one, on the left side, we map that baseboard to a package substrate, and we map the OEMs to chiplets. Now, the difference being the OEMs are all look identical on the UBB, but in our case, the chiplets have different functionality, but they are built such that they can be plug and play on this package substrate. So I see this as one step towards Ali's next goal, which is on the right side, creating a larger platform which maps to a board. And each subsystem of that platform is everything that I've drawn on the left, the package substrate and chiplets going into it. So I've broken the step that goes directly to the platform subsystem to one intermediate step in between, which is, defining the substrate and the chiplets that can go on it and having a standard form factor for that. Now, if we think about it, there are really two different types of substrates. One is in a broad category. One is the organic laminate, which everyone is used to and loves because it's cheap. And the second part is the advanced packaging, and that could be using RDL interposer or silicon interposer, or any new fancy ones that come up with time. They are more expensive, but they form a different category altogether. There are different interfaces meant for one and or the other. There are different package types meant for one and the other, and there are different performance goals for one and the other. So my idea was we create two standards for it. One is laminate, one is not laminate, and define for those what kind of chiplets can go in, which basically means these are the interfaces that are allowed, because one works with one type and the one works with the other. That itself now becomes step one of this goal. And then the next set mapping is to go to the level that Ali's looking at, which is the next higher level of defining a board with all the voltage regulators, depending on what supplies you're bringing in, and defining the subsystem as that particular package with the chiplets. So I found the meeting last week helped me create this analogy, but not directly to the platform, but to a smaller in-between step going to the next step. So if you go to the next slide, Ali. So I sort of see this as the first step and the second step. One is just mapping the UBB to a package substrate. And when I say map, I'm using the term loosely. It's not like the standard has to carry over. I'm just seeing it as an analogy for us to look at. And the OEM maps to the chiplets. And here we create the two categories of, these are the two possibilities. And once we have those defined, the next step is you modularize that further into, here's the baseboard, and these are the subsystems that can fall into it, where each substance is everything that you created in step one, falling into the piece. And can we create standards for something like this? Does it make sense to do that? Will it enable a good ecosystem for multiple users and make life easier in a more plug and play manner? So those were my thoughts going into it, and open for discussion, opinions, feedback.
Excellent, Anu. I love it. Thank you.
So, hey,
well, that's a good one. I like it.
Hey, Anu, this is DJ. I have a quick question actually here, especially on the goals and form factor. As we know from the last week's discussion, OAM is a form factor and NIC 3.0 is a form factor. And substantial amount of work has been done to actually not only define and create these form factors, but a small ecosystem has emerged around each of them, which is pretty robust. So the question I have is, should we not strive to actually use those form factors? OAM is a form factor, and perhaps ODSA based system in package can fit in OAM type of a form factor to deliver a solution of a subsystem, which can then be easily adopted because people can test it through UBB. Maybe there are software interfaces which have been defined in OAM. So are you thinking of OAM as a form factor as well, which can be leveraged?
DJ,
that was, sorry, go on, Anu.
No, go ahead.
Yeah, DJ, that was my original suggestion, and I've been looking at this for some time. Obviously, the pushback last week when I mentioned it was, when you look at the OAM, the size of it, it's not viable as a substrate, or that's the opinion, because you can't keep it flat and all the rest of it. Although we do have a couple of members, I don't think they're on right now, that are presenting some interesting substrates that may be able to keep the coplanarity, etc. So if you look at from a signal integrity perspective, if you look at the OAM system today, it's got a 30 dB budget and you consume 8 dBs on the OAM itself. So when you're going OAM to OAM, you've consumed 16, over 50% of the budget on the modules. And we're trying to route 112 gig between modules on the UBB, and we can't without retimers because we don't have enough budget. So I'm saying, why the hell do we need 8 dBs on the module? And we've got, essentially, if you look at what's happened with the OAM, you look at what's happening inside packages, the packages is evolved, so they're sucking in part of the PDN, the power distribution network. So you've got capacitors on the packages. But when you look at 0.7 volts and 800 amps, you've got all these unnecessary balls consuming IO, and it's causing you lots of IO challenges. And so, and if you really look at the OAM module, it's really a large package. You used to plug a processor chip into an LGA socket, but NVIDIA started, and that's what OAM copied effectively, is let's solder down the processor and wire it to a high-speed connector and add the power supplies. We've sucked the memory onto the package because it's HBM. So these OAMs don't have any external memory. And so literally an OAM module is just power supplies, clock distribution, sideband management, and IO connectors. So why not cut out the middleman and get rid of the substrate package and make the mezzanine module itself a substrate package? And that's been my desire for a long time. And then if we route straight from bare die bumps or chiplet bumps to connectors, we can possibly reduce the OAM budget for the high-speed signals from 8 dBs down to maybe sub 1 dB, especially if you put an IO chiplet straight over the top of a connector on your substrate. So what I'm trying to do is you've got to cross the boundaries of the silos of our industry. Our industry is, I'm not a package guy. I've got to put up with whatever the ball out is that the package guys give us. I'm a systems guy, so therefore I've got to do that, or a connector guy. And we need to cut across the silos, and I think that's what this work group can do. And I think with where we're going here is doing, which is why I love it. So hopefully that helps.
Yeah. So
I'd like to chime in here a little bit. Certainly, it's interesting to try to put chiplets and pieces of silicon on a bigger OAM like substrate, and I think that's maybe a good thing. I think there's going to be a transitional time frame in there at some point where it's going to be good to have chiplets in their own natural environment as we wait for that natural environment to translate over to something that could be actually put on a substrate. So certainly it gets rid of a packaging point. It does some great things there. I think that's all decent. But one of the things we should consider is that, how to get there from here and what the transitional steps may be using available technology.
So I have a slightly different take. This is Suresh. What I had in mind was to completely leverage the all the work that DJ mentioned. The UBB and OM have defined the integration points for the chassis, and then from the chassis onto the UBB. Onto the OEM or the NIC card. So for example, the OEM, what it defines is a bunch of power and IO connections and whatever clocks that come into the OEM module. We have real estate on the board on which to either include one or more chiplet SIPs, if you will. And I think what those SIP configuration should be is probably the most interesting part of what we should be talking about. And that way you would leverage all the stuff that has been done in OCP thus far. And what we know is to the OEM or the NIC card, you know what kinds of power is going to come in and what kind of IOs are going to come in. And there's a lot. And then the question is, given that, what can you do in terms of one or more chiplets, whether you create SIP modules or natively embed them? Yes, there are challenges around warpage and all this kind of stuff, but I think in that way you leverage completely all the work that has been done in those other groups.
So I agree,
Yeah,
Suresh.
exactly.
We should definitely leverage what's been done. I just broke it up into an intermediate step where the SIP is representative of the package substrate and chiplets, and the platform is really defined as a UBB, and the subsystem is sort of follows the OEM spec. Because it makes a lot more sense to leverage what's already been done than reinvent that piece.
Yeah, I agree, Anu. I think referring to UBB and OEM might be confusing people in terms of, I know you're using that as an analogy.
It's just an analogy, yes, because it just struck me when I saw it last time that we could, make more sense of it this way.
But I think if I understand your intent, you leverage the OEM as is, but on it you have the SIP would be the equivalent of something like the UBB, and then you have chiplets on it. Or the OEM would be now become like your UBB, and then the chiplet SIPs are your equivalent of OEM, kind of what Alan referred to as fractals in a previous.
Yeah, I was going to say, so that's more of a continuum like the fractals. Exactly.
Oh, there you go. We just need some physics in here now.
Yeah, so I feel the same what Suresh mentioned. In fact, we need to reuse form factors where we can, so we can kind of build momentum from other projects. One other suggestion I would give is, you also heard from Damien for OCP NIC 3.0 that they are looking for new areas of application. So what we could do additionally is, if we have some interesting new requirements like what you were suggesting, Anu, instead of trying to solve it ourselves, we should go to OCP NIC 3.0 meeting and explain to them what is it that we need, ODSA needs, and let them go and solve it for us. So that way we are not solving everything. We are asking other groups where it makes sense to solve portion of problems. They already have the expertise. It may be much faster for them to redesign some of their systems so that it becomes available for a use case for ODSA based devices. And then, when it comes to SIP, we can, use inspiration from UBB and OEM, but because it's, completely different form factor, we also have liberty to use our own creativity, right? I mean, we are not leveraging that work in any sense other than just looking at the architecture, understanding, how interconnect between all these 8 accelerators has been done.
Yes.
Perhaps it may be of use, it may not be of use. But my main suggestion is, additionally, let's think of ways to go and present it to these groups, OAM and NIC 3.0, and tell them what we want at a subsystem level, and let them go and work on it for us.
Right.
Yeah, it might be along the lines of adding more types of IOs or power or whatever it is, that the current definition may not be adequate.
Yeah, I agree. And it really, this was, as Suresh says, it's confusing, but it's just an analogy where some of it we'd have to do ourselves in terms of the lower level putting together on a sub if we're going to go with the substrate idea, or if we go with, the way Alan says, directly go into the board. We'd have to figure that piece out. Some of it a lot of it we can leverage at the higher system level, but at the base level, we may have to do some of the creativity ourselves, as DJ suggested.
Well, that maybe that's the first thing, is let's define our scope versus the scope that would be outside of it. And, can we define it in terms of kind of packaging? Like we're basically bare die to plastic potting, right? And then beyond that, that's where it would be something like a NIC 3.0 or OAM would become the next level of abstraction, or kind of modularity.
Wait, the OAM guys made one choice, which we've sort of always gotten close to, but never actually made. They made all the boards the exact same size, no matter what the components requirements are. Right? I mean, if your component doesn't need as much power as the board offers you, that's okay. If you take less area, still your problem. If you need more, try to squeeze in. But that allowed them to sort of make a fairly standard baseboard. So if you carry on the baseboard to substrate analogy, is there merit in sort of giving each chiplet uniform orientation, space, functionality?
The way I see that, Bappy, is inside the wider OCP is the NIC 3.0 is like, I characterize it as that sort of sub 100 watts. Is that or the EDSFF form factors, if you're seeing them, which are based what NIC 3.0 is based on. And I say the OAM is 200 watts to a kilowatt. So it's sort of a power driven thing as much as anything.
Right. But the point is, doesn't matter what, like, JP made that choice on the ODSA POC as well. Doesn't matter what your functionality is, you get this orientation, this IO, and this much space.
Right.
And yeah. So I see Ali. So is that a choice we want to make? I guess is my question, not a recommendation.
Sure. In my original proposal, there had been standardized dimensions. I would say that, maybe we can be a little bit more relaxed. Instead of saying it has to have one standard dimension, you have a set of 4 or 6 or something, depending on, whether it's like a 1U or a 2U or a 2 by 2U type of thing, right? To make things fit. And then in terms of budgeting, I would think there's a thermal budget based on the size of the subsystem. So then you could define it that way. But then the standard size would have a standard budget, just like they've done in these others. So I think that maps really closely and was what I was kind of imagining from the beginning.
Yeah, Ali, on that block diagram, you don't have any IO. Is there a reason for that? Or are you just...
In this, well, remember one of my things was to come up with a little bit more of a zoo of subsystems. So I threw together a couple things but anybody else is welcome to propose something, because I don't know all the functionality we need, but yeah, IO is important. Here I have one that's maybe kind of getting in that direction or facilitating IO, right? I don't have an IO chiplet for that voltage, but and you can see where I'm going here,
I think this is a good picture. This is where I'm coming from as well. If I'm a super duper processor specialist, I have a fantastic architecture for a particular acceleration or processor AI, GPU, FPGA, whatever you want to call it. I want to innovate at what I'm best at. If I have to choose memory, IO, or local HBM or whatever, local memory, transceiver IO, or chiplet to chiplet, I have to make a decision of what the balance is right for my processor. Whereas in reality, and therefore I constrain myself by my IO choice. So I might have the best processor in the world, but if I guess wrong on the balance of memory IO, I may miss a market opportunity. If this group can normalize to one processor chiplet interface to all of the IO, obviously power is different and the timing maybe, but the memory and the transceivers for sure, memory being HBM, on-chip memory, off-chip memory, and communication IO, then I think we're onto a winner here, as well as a modularity piece we're talking about here of making this pluggable and scalable.
Ali, I have a question. The way you've drawn the subsystem zoo, can we think of it as prepackaged chiplets that offer certain functionality, and you could divide them up into, like you've shown here, either it's a CPU subsystem or memory, or it could be some other function IO, but people are free to innovate or produce different things, but they all have some standard power and IO footprints. Is that a good way to think about this?
That's a good way to think about it, except that they're not packaged. So I would say that these are going to go directly on the SIP substrate. Right. And they may be multi-die, they may be one die. So within the the substrate would provide the interconnect, and then the substrate, and then at the boundaries of a subsystem, you would see, here's a standard data interface, here's a pin layout that you need in order to do massive serial across, from one subsystem to another. Standard voltage rails that can come in, a power budget, based on area, or thermal budget based on area, let's say, or, and so on. Maybe I was thinking test interfaces. There might be a power management interface. So I'm stealing some of these ideas from server boards also. They'll have a management system that kind of runs in the background behind all the, heavy number crunching. And so similarly, when you have a bunch of subsystems, you might want to have a management backend to, monitor traffic or check thermals or manage power and things like that. So that was my idea. But yeah, I would say that there's no plastic over these yet. So they're still bare die, but they're kind of a block together that supports it to be tied into the broader fabric of the substrate. And I would imagine, I was looking at the OEM module specification, so we could even have pin maps, right? And I think we already have that for some of our standard interfaces. And then there's these mesh suggestions. So, mapping these meshes, because you can imagine that when you're going to put together a bunch of SIPs, a bunch of processors or processing capabilities into a SIP, you may have an array of them, 4x4 of 4x cores, right, or something, and then you want to have an interconnect. So, supporting that in an explicit way in the interconnect substrate is, I think, another piece of a platform specification. But I would love for people to think of new members for the zoo also, so we can broaden our horizons here.
So Ali, I have a question. So I think you are saying this could be, say, for instance, if we look at the memory and power, this, and you're saying this could be chiplet or this could be die mounted on a substrate. Did I get it right?
I would say the subsystem is not yet bonded on the substrate.
But then if they are not bonded on a substrate, then how are they communicating with each other? Is it a type of SoC?
the substrate will provide the interconnects within a subsystem, but also between subsystems.
So let's say if you're saying they will provide the connection between the subsystem, so these are dies or these are chiplets?
Can you define the difference between
each,
a die and a chiplet?
So for instance, if I look at the center image, which says memory and power, so these are memory for chiplets or memory for dies?
I mean, this is memory. Those are for. I mean, this can be implemented in any way you want. I would say it could be 5 dies. It could be 1 die.
No. So the reason I'm
yeah.
asking, Ali, is if they are dies, then how are they different from today MCM package? So if you look at any MCM package, which has 3 or 4 dies mounted on a substrate, and substrate is a medium through which different dies are talking to each other. So how it is different from them?
How is it different from them? I mean, in a sense, it's not that different from them, except the same substrate is involved in within MCM, intra MCM communication and inter MCM communication.
But if that's the case, if you look at, I'm assuming here your underlying assumption is these are organic substrate, right?
I don't think there's an underlying assumption, but I don't see why it couldn't also happen, on a silicon substrate or one of the advanced substrates or RDL.
So even if it's a silicon substrate, so like for instance, there are limitations how big you can make silicon substrate or organic substrate. And if you look at most of the accelerator are already hitting those limits, or most of the high performance computing product are hitting those. So if I look at one subsystem, for instance, on the leftmost side, which says processor, memory, ESD, and other things, that itself on a substrate, whether it is on a silicon substrate or an organic substrate, are already of the order of 100 by 100, or the largest substrate which is available today in the industry. So I am saying, how will we mount multiple subsystem on a same substrate when that substrate doesn't exist today?
So, which is kind of why I was talking about it as 2 separate pieces. One is performance based. You have these subsystems as either a laminate or you have it as an advanced packaging piece.
But Anu, even if you are thinking of advanced packaging, let's say we are RDL interposer or a silicon interposer. We know silicon interposer are already, TSMC is doing up to 3 times or some 3.5 times the reticle size, right? So which is itself is one of the NVIDIA or AMD product, which is what you call is a one subsystem, or you call it as multiple subsystem?
I believe, yeah, okay. What you're saying is if you're stitching multiple of them together, is that a single subsystem or is that a multiple subsystem?
Yeah, and it is happening today. And I'm saying, if from that definition standpoint, if we say EPIC, let's say just for the discussion, we took AMD EPIC, which is fairly like about 2x or 3x of the reticle size already. So would you call that as a combination of multiple subsystem, or it's just one subsystem? And if it is one subsystem, how would you put another subsystem on any medium for that matter?
So in my imagination, the EPIC is multiple subsystems.
So if that's the case, Ali, so that is already happening in the market. So I'm trying to understand, how are we differentiating this, which is already happening in the ecosystem?
Well,
maybe
let
I
me
didn't
give you an
understand
example.
quite.
Let's see, I don't have it up, but TSMC has on their website several different options for multi-die integration. So this is going in that direction, and I think the difference really is about defining much more than just saying, okay, here's the package. So they basically say, here's the package, and then based on that, you can put together what you want, and we'll work with you, right? But what I'm saying is that, say, okay, here's the package, but here's a bunch of other criteria that you need to do for you to be able to plug and play your subsystem into the package. And then if we have all this, then it's very easy to take different pieces of the zoo and put them together. And you know, this is addressing both signal interfaces, but also the product integration and test development and those kind of things in order to really make it a fast process from deciding these are the pieces of the zoo that I want, you know, the resources, and how to put it together and
Ali,
how to turn it into a product. Yeah.
Ali, in this case, who would own this? It is the end customer for which they will own the different aspect of component in getting into a packaging, or like, in your mind, who would own that? Because today it's owned by the customer, whether it is NVIDIA or AMD.
I mean, you're saying these constraints around, like, so what this would be a definition of what the substrate provides. Like, for example, what's the power grid? What is the you know, voltages that are available to to each subsystem, for example, right? So that's not something that's defined in like TSMC or anybody's packaging platform. But if you have that, then someone can develop. So what I'm trying to say is that, you know, in the TSMC's vision or something, most of the die have to be, there's a lot of co-design of all the die, right, to get everything working and this system going, right? What I want to do is eliminate co-design by putting boundaries and saying, if it fits within these boundaries, then you can just stick it on. And now you can design your die, or if you want to use multi-die to fit within those boundaries, that's also fine. So that's why I call it subsystem and not, let's say, each of them a chiplet, because the subsystem could be one chiplet or multiple chiplets. Sorry, go ahead.
If I look at AMD, it has 2 core die and I think 8 or 16 IO chiplets around the core die, at least in their latest EPIC they have.
Isn't it the opposite way? Don't they have multiple core die and then one big
2 core
IO?
dies. So my understanding is they have 2 core dies and then you know, around 8 or something like IO chiplet. But in order to function those, they need 2 core dies. So those 2 core dies are not independent, and likewise those IO chiplets are not independent either.
They're not. I mean, they're not independent in order to create the functionality, but you know, they are. And I wouldn't say that. Well, we can define independence also, right? In the sense that a subsystem independent in the sense that it gets everything it needs from the substrate resources that are provided, right? But it is not independent in the sense that it can be a device by itself necessarily. I mean, it could be, I guess, if you had, you know, like one of these memory subsystems or something. But you know,
well, I mean,
some of these
the IO can become a separate, you know, a standalone chiplet if it has a standard interface. When we look at what AMD did, it's custom. What we're trying to do is standardize.
So we are addressing the interface problem, right?
We do have to address interface problems, which is what I'm saying is it divides it clear into laminate versus non-laminate, because the interface, the bandwidth and the performance of the interface is highly dependent on the type of substrate you use. What AMD does is custom to them. I mean, I think they presented at the virtual summit, and they are open to having standard interfaces, but everything they do is custom and works for them. What we'd like to do is have something that's standardized and works for other people who are not with deep pockets like AMD.
Sure. So how does the bow interface or the bow test chip work fit into this? Because that's the idea of OCP to standardize the interface.
Die-to-die interface. So
exactly. So bow provides that.
Right.
Right. I mean, the bow test chip is to validate that the performance of that interface. There are multiple options, and Suresh is the authority here. But there's multiple options in that to go for different bandwidth possibilities.
Yes.
But it does validate the performance and create a standard that can be reused.
So we're coming to the end of the time. So I just want to guide the discussion a little bit in the sense that, again, I think we still working on coming to an alignment on the definition of you know, what a subsystem looks like. I hope this is helping, you know, by putting together a little bit of a zoo.
may I ask you something? Just to Ravi's point, if I understand what Ali and Anu and everybody are proposing, what AMD likely has some design rules for how to mix and merge these components so they can all, where the teams can go off and design them independently. And I believe the intent here, and then those design rules extend beyond the simply the actual die-to-die PHY, but to the orientation, to the power budget, etc. And I'm guessing the proposal is, hey, why don't we have similar design rules so that independent companies can integrate on a substrate? At least that's where I'm sort of, that's the
I think
add-on
that sums it up really well.
Yep.
I think that sums it up. And what the idea is that allow people to proliferate this zoo, right? Because they have a design a constraint workspace to work within, and then they can be creative inside of that, and then people can put them together for the next level of creativity.
I just wanted to mention one thing. I don't know if Elko is on, but all the OSATs have design rules for how close chips can be and so on and so forth, and how many you can have in a certain area. Likewise, TSMC, they have a recipe for how they want to see different die. And they are pretty, sorry to use the term, anal about it. And if you deviate from that, then you have to work really closely with them to make sure you're getting the yields and all that. This is for advanced packaging. So that kind of substrate, whether it's advanced packaging or organic substrates, each substrate vendor has their rules. I think what we are talking about is some standardization of, just like the OEM says, here are the clock, power, and IOs that will come in and out of this OEM. If you're going to define these subsystems, I think that's what you're striving for, in my understanding, Ali, which is what are the inputs and outputs and power and thermal profile for such a subsystem. That's the thing you want to get to define. Is that correct?
Yep. And some of the things that you talked about are here already also, and they're going to be driven by what is the integration technology. So I think the first step to define a platform is to say, what is the integration technology? And you have to actually say, okay, this is the layer stack from die to the outside world and between die. Then from there, then we can work out all of these things in the most optimal way to give most flexibility to the subsystem zoo, but also balancing the flexibility for the subsystems, but also allowing interoperability. So then what I want to do from here is now, is there a consensus that this would be something useful to do? And then if so, let's put together a white paper to define why, what is the problem that we're solving? So I think I wrote down somewhere here, that I had written an agenda here somewhere. White paper, define the problem. We really want to have a third party, an open ecosystem for assembling, chiplet-based SIPs, right? And then our goal would be to provide a space or a constraint space within which companies can innovate and then be able to be interoperable, and then propose the solution as platform, and then have a call to action somehow. And the depth to which we actually define a platform is probably going to be minimal, but we can start by saying, okay, an example of a platform could be an organic substrate, and that's going to lead to these types of constraints. So that starts to give people an idea of what that platform means. So let me put it out there. We only have a couple minutes. Who would be interested in helping with such a white paper? Do we have enough alignment to do that? Or do I need to have another open discussion like this?
So Ali, this is Ravi. I'm happy to help, but maybe you and I can talk offline. I really want to understand what are we like from a problem statement, because if you're looking at design rules, so we are getting into technical specification of how a chiplet product should be put together. Is that in an open ecosystem? Right? Is that's what we are trying to look?
That's what we're trying to do.
Okay. So yeah, I'm happy to help.
I think I believe there's an intermediate step of, is it valuable if we come up with these rules? That's the big open question. And and that's what is there value in doing that, and how do you quantify any potential value? That seems to be a bigger
I
open
will
question.
throw in one thing where it might be valuable. If you define a common footprint for, let's take the one that is pretty standard today, right? Memories, multiple vendors supply memories, but the reason that works is there's a common footprint, and you have second sourcing options, and that's valuable to system integrators because they don't get tied into one vendor. So if we want to facilitate a certain type of chiplet that multiple vendors, or a chiplet platform, as Ali is calling it, that multiple vendors can supply, but then to be able to drop and replace one with another, then there's a huge value to doing this, in my opinion.
That would almost mean defining more, like for a particular member of the zoo, we would define what its IO pattern looks like, or interconnect pattern. It would be defining a lot more than. So that's interesting. So we have to define which level is drop-in, right? Is it the SIP level of drop-in, or is it the subsystem level of drop-in? But anyway, sorry, I don't want to. We're already out of time, so we're going to lose people. But I really appreciate the time. Anybody whose name I might have written down, I'm definitely going to be asking you to help with this paper. Let me put together kind of an outline and some of the core talking points of that outline that I did, and I'll share that around, and then host a separate discussion where we see where to take it.
Hey, thanks, Ali, for giving me the opportunity to start, and I'm sorry if I took up too much of the time today.
Not at all.
No, Anu, actually, your presentation was very inspiring. Honestly, I'm very happy to see that based on what happened last week, people here are already building on that thought process, which is the exact, behavior we are looking for from everyone. So thank you for taking this time to share your thought process, and please, I might reach out to you. I think somebody like you should go eventually and talk to folks at OCP NIC 3.0 OAM groups and share the vision of ODSA with these subgroups and tell them what we want. So you could be a good representative to do that. Thank you.
Thanks, DJ.
Anu, I don't know if you are available, but the next business work group meeting which we have, which I think would be useful if you like to join.
Sure, just let me know and I'll look at my calendar. Thanks.
Sure.
Yeah, I gotta go now. Thanks, everyone.
Thanks.
All right, nicely done.
Thank you. Bye.
Thanks all.